Welcome back, everybody. In this video, we're going to be taking a look at our next topic inside of Enterprise, which is going to be migrating away from just strictly layer 2 technologies, and now we're going to be taking advantage of layer 3. So what I'm going to first focus on is the different routing capabilities you can do for inter-VLAN routing. So we're going to focus in this video with layer 3 switching, which is very commonly deployed in most enterprise networks, both in the branch locations, in the enterprise headquarters, colo data centers, so on and so forth. It's very widely deployed. So I figured, you know what, it makes a lot of sense to do it, and you're going to need to know both router on a stick and layer 3 switching, so we might as well just cover both. So the switches are already good to go. What I'm going to go do is I'm going to do a little bit of some different tactics to show you some capabilities that are out there. The first tactic that I'm going to show you is where we have R25 and R26 will just be acting as endpoints in VLAN 11 and 12 respectively. And then what we will do is we will put an SPI on 30 and 31, and we will simply have it there to work. So we'll have a default gateway, and actually on 30 I'll put it on. I won't put it on 31. I'll put it on 30, not 31. But we'll give it an IP address and stuff like that so we can have a default gateway. So 25 will be able to ping 26 by the end of this video. Another tactic that's available to us that isn't as widely known about is when you need to go and test out more numerous capabilities where to R28, the connection between 28 and 30, this link right here would actually be configured as a trunk link, and 28 would have multiple sub-interfaces. So almost like a router on a stick type of a design. That's actually what it literally would be. And so you can have multiple connections coming in down here. What does that correlate directly towards? Think of that connecting down to a ESXi server. And you have a trunk link down here, and you have a bunch of interfaces, VM kernel adapters that you've got set up for ping reachability to make sure that the actual connection's up and running, so you can test connectivity from the switch down to the server and things like that. So what I'm going to go ahead and do is the first portion of this, and then I'll show you the second portion. So the first portion is going to be the more direct one. So let's go ahead and pull up Secure CRT. And I will then be showing you in another video how to do router on a stick on both an iOS router and an iOS XR router. So that'll be kind of cool. So on switch 29, let's take a look at this configuration and do a show VLAN brief. Here we have VLAN 11. We have is set up gig 1/0, and we have R20 or VLAN 12, 27, and 28. I'm going to go back to 30, and I'm going to do a show VLAN brief. I'm going to come in here and type in VLAN 12. The name is actually going to be R26, R27, R28. And then VLAN 11 will be the same thing, but this will just be R25. Right? So we come back down to 29, we hit the up arrow, and now what will end up having to happen is we'll have to trigger an update. So now 29, that should eventually get pushed. We need to probably create a VTP update. Oh, you know why? I know why. Show VTP status. We're in transparent mode. We're not going to listen. So if I was to go to VTP mode client, do show VTP status, or status, and do show VLAN brief, now everything has been updated. So I was like, why is that not updating? That's why. So there we have it. So now what we're going to go is on switch 30 is, let me just double check. Let's do show IP route. I'm not sure if it's actually working. Okay, so it is routing. So let me go and turn that off. So no IP route, or no IP routing. Layer 3 switching. What is it that you're trying to accomplish? Well, layer 3 switching is basically taking a switch virtual interface, an SVI, and you're actually going out and creating a interface for that particular VLAN. Because if you don't have an interface inside that VLAN, meaning it can't escape out, then you need to give it some way of getting out. In other words, the traffic inside of that VLAN needs an exit point in order for traffic between VLANs to be able to move between each other. The only way to accomplish that is by doing inter-VLAN routing. And so there's two ways. You have layer 3 switching and you have router on a stick. We'll take a look at router on a stick in an upcoming video. This video we're going to be focusing on layer 3 switching. So in order for this to work, I turned routing off just to prove to you exactly how this works. So we do show IP route again. IP routing has been disabled. So this is a flat layer 2 switch at this point. Now if I was to come in here and type in do show VLAN brief, you'll see that we have a number of VLANs. VLAN 11, 12, 21 through 28, right? We have a lot of devices, or a lot of VLANs created. Nobody's really in any of those VLANs, but we can make it look like they are if we wanted to. So the way that we would accomplish this is we would actually type in interface and then the VLAN itself. We'll say VLAN 11. Now I can come in here and type an IP address is going to be 10.1.1. And I'll say 254. Actually, I'll do .30/24. Now I have a interface inside of that VLAN with an IP address. And so, it's shut down. It's actually not working at the moment, so I have to no shut it. If you're using Packet Tracer or some other emulator, or I should say simulator, Packet Tracer brings the SVI up out of the gate. It's not how it works in the real world. You have to no shut the interface. So I look at the do show IP interface brief, and there it is. So now if I do ping 10.1.1.25, do ping, I should be able to get a ping reply from R25, and I can. That's a great sign. Now, I can also do the same thing for VLAN 12. So let's exit out of here, type in interface VLAN 12, type in, and let's wait for it to do its thing. It goes to automatically down. Now, in order for an SPI to come up, there needs to be at least one port with that VLAN enabled on it in the up state, meaning either an access port or a trunk port needs to have that particular VLAN ID associated to it. So, example, if gig 0/3 and gig 0/2 did not allow VLAN 11 to traverse it, interface VLAN 11 would actually go down. So if I was to actually demonstrate it, I'll demonstrate this here in just a minute. It should work. I haven't tested it out, but if you don't have an interface up in that VLAN, then the SPI itself won't come online. There needs to be some sort of active broadcast traffic or an interface in the data plane that VLAN is enabled on in the up state, or else the SPI won't come online. So I'm going to type an IP address is going to be 10.1.2.30/24. I'm going to go ahead and no shut it and bring that guy online. Now VLAN 12 is online. Do show IP interface brief. I'm going to go ahead and do ping 10.1.2.26, 27, and 28. Okay, so I can ping everybody from here. The question is, on R25, if I do a show ARP, ping 10.1.2.26. No bueno, right? It's not going to work. Why is it not going to work? Well, when we get up to switch 30 and we look at it trying to send the traffic, we look at the do show IP route, there is no interfaces. Routing's turned off, right? In order for this to work, we need to have routing turned on. So I'm going to actually type in here IP routing. Then I'm going to do a show IP route again. Now you'll see multiple interfaces showing up, VLAN 11, VLAN 12, and we have them set up in the routing table. And that's what you'd expect to see. This is the appropriate output that you need to be seeing in order for this to work. If I go back to 25 and I hit the up arrow, it's going to take a couple of seconds. But once it figures out what's going on, we should get a response from Oh, you know why? Show IP route. So in this case here, I have routing turned on these devices. So there's two ways you can fix this. I don't have just a PC with the default gateway set up. There's two ways you can fix this. I'll do the first one on R25. I'll come in here and type in IP route to 10.1.1.30. Just create a default route, right? And on R26, the other way you can do it is no IP routing. Turn routing off. Now if I go back to 25, drop out of global config, hit the up arrow, and ping, give it a second. The ping works now. Why didn't it work before? Because I had routing enabled. With R25, we were looking at the routing table, and it's like, well, I don't know how to get to 10.1.2. So I'm just going to drop the traffic. You know, it's just like it throws it away. It doesn't know what to do with it. By creating a default route, show IP route, I said, you know what, if you don't know what to do with something, send it to switch 30. Switch 30 will go figure it out. On R26, do show IP route. Like, you know what? I don't really care. Now I can come in here and type in IP default gateway is 10.1.2.30. That would work. Do show IP route. It's really not going to help it. The only time this would actually be a benefit is if I wanted to connect to this device for like management purposes or something along those lines. It's how you would allow layer 3 connectivity into a layer 2 only enabled device. So if you had a layer 2 only switch, you could create a default gateway to a next hop IP that was reachable, and then any traffic that came down to that switch for management or SNMP or something along those lines, you'd be able to use this command in order to allow that to happen. So yeah, that's inter-VLAN routing with layer 3 switching. Pretty straightforward stuff. Now if I go to 25 and I hit the up arrow and I do 27, give that a second, same problem is going to happen, right? Because we don't have 27 set up with a default route or anything like that. We need to basically tell it, if you don't know how to return the traffic, go ahead and send it to switch 30 on VLAN 12, something along those lines. So I'm not going to do that because I've already shown you guys how to resolve that problem. So you can either create a default route or turn routing off and go that route with it. So that's basically layer 3 switching in a nutshell. If I come up here to this guy and do show IP route, nothing really changes. If I do show ARP, you can see that there's a bunch of devices in this, or a bunch of, we have the interface VLAN, and then we have the broadcast domains and stuff like that. One thing I want to be very clear here is that if you create an interface VLAN, but you don't create the VLAN itself, then nothing's going to happen. Because creating the interface VLAN is not the same thing as creating the VLAN itself. So the interface VLAN can be used as a egress point or an ingress point for traffic coming from or going to the VLAN. So if you don't need traffic to stay what they call east-west, within inside of the VLAN itself, if you need to leave the VLAN to go somewhere else, I don't care where you're going, then you need to have an egress point, which is going to be the interface VLAN or the switch virtual interface. It's a logical interface on the switch that you can use for routing purposes. So I could take this and I could enable routing and then get switch 30 and XRV4 up and running, and then they can exchange routes with each other, and we could go from XRV4 to switch 30 and do inter-VLAN routing all day long. Everybody would be happy. Pretty straightforward stuff. Now with that being said, there are other ways of looking at this. We'll talk about router on a stick in a different video. Actually, I'm going to do it twice, once on CSR, once on iOS, once on iOS XR, so you guys can see how that works. But that's basically it. Now let's talk briefly about the recursion process, because whenever we look at how this comes into play, if we do a show interface VLAN 11 and we look at 12, you'll notice that each one of these has a different MAC address. So at Ethernet SPI right here, we see that the last four is 800B. We come down here, we have 800C. So every time a new SPI is created, a new MAC address is generated. And that's how we provide separation logically between the SPIs. So now when I go to R25 and I do a show ARP, I'm looking at 30 as 800B. But if I look at R26, I do a show ARP, I'm looking at 800C. Now what's going to end up happening, if you were to look at this from the perspective of switch 30 and you were to do a show IP route or a show ARP or a show MAC address table dynamic, what you're going to see is you need to understand the recursion process. So the way this will work is if I have traffic that comes in on the 10.1 network here, going out to the 10.1.2 network here, I know I need to route them from VLAN 11 to VLAN 12 or VLAN 12 to VLAN 11, depending on the flow of the traffic. What's going to end up happening is, from a routing perspective, it's not obvious because we're dealing with logical interfaces instead of physical interfaces like you would routing on R28 towards switch 30, for example. If R28 needed to reach something on switch 30, R28 would recurse to gig 0/0. We don't have that here unless we were to flip an interface on the switch to be no switch port or turn it into a layer 3 interface, then that would change things. But right now we don't have that set up right now. So another variation of this would be you can't really rely on the routing table to figure out where to go. The routing table is not a one-stop shop. You actually have to take this a couple steps further. You could look at the ARP table and say, okay, I need to figure out based off of the destination. So here I am to get to router 25 in VLAN 11 or to get to router 26 in VLAN 12. I can go out to any one of these interfaces, but that still doesn't tell you what interface it's going out of. You can go down to the MAC address table and say, okay, in order to get to VLAN 11 for my connection down to R25, I need to go out gig 0/2. And that's how you would look at that. In order for VLAN 12, I need to go out gig 0/2 as well. And that's basically how you would look at this. You would look at it from that perspective, and you wouldn't look at the routing table, and you wouldn't look at the ARP table. These are just going to tell you that routing is enabled and traffic between the devices should work. What particular interface the traffic comes in on, you have to do a second layer of recursion, which is looking at the MAC address table. What MAC was learned on what port, and how does that correlate? That type of stuff. And that's pretty much it. That's pretty much layer 3 switching in a nutshell. There's really not too much more to it than that. You can do dynamic routing if you want to. We'll take a look at that down the road a little bit later on and stuff like that, but that's basically what you need to know for layer 3 switching. If you have any questions, please let me know in the comment section below. But until next time, guys, thanks so much for stopping by, and we'll catch you guys in the next video.